Next fit.
You'll fill up the bins at hand, and if the items you're on doesn't fit on the bin, then you move into the next bin.
Okay, the capacity is 16, so we just take the numbers in order. First one will be 6 and 8. The next one will be 9, 4, and 3. The next one will be 2 and 10. The next one will be 7. Next one will be 14. Next one will be 12. Next one will be 6, 2, 3, and 1. Next one should be 10. Next one is 11. Then 13. And then the last one is 5. The minimum number of bins is 11.
First fit.
With every item, you start at the first open bin and find the first bin it will fit into. If there are no bins open that it will fit into, then start a new one.
Start off with the first bin. It's 6 and 8. Second bin will be 9, 4, and 3. And that bin is closed. Then you go to 2, but you would go back to the first bin. And now that bin is closed. 10 in the third bin. 7 in the fourth bin. 14 the third. 12 in the next bin. Then you take 6 and put it back in the third bin, and then that bin is closed. 2 would go in the fourth bin, along with 3 and 1. Then you would do 10 in a new bin, 11 in a new bin, 13 in a new bin. You take 5 and put it back in the 10 bin because that is the first bin that it can fit into. And then our minimum number of bins would be 9.
Best fit.
You don't worry about order at all. Instead, you look at all of the items at once, find perfect or near perfect matches for the bins.
Okay, so we're going to start with 6 and 10 in the first bin. So that's closed. And then 9 and 7. That's closed too. And then 14 and 2. And then 12 and 4. These are all closed. And 13 and 3. Then 8, 6, and 2. The next one will be 10, 5, and 1. And they're all closed, all of the last ones. And then the last one will be 11 and 3, but that doesn't close up. So the number of bins is 8.
Worst fit.
You take the item at hand and put it into the open bin with the most room left. Only when it will not fit in any current open bin do you start a new one.
We would start off with 6 in the first bin, move to 8 in the same bin, which that would be 14. And you always want to put the numbers up top to help you with this one. 9 would be in the next bin because it doesn't fit in there. 4 would also go in the second bin, along with 3, and that adds up to 13 first. With the 3, it ends up being 16, and it's closed. And then you have 2 next, which would go back to your first bin, which that adds up to be 16, and it's closed. 10 would go in your third bin. 7 would go in your fourth bin. 14 would go in the next bin. And then 12 would go in the next bin. 6 would go back up to 7 because it is the least amount in any bins, which would end up being 13. And then 2 would go in the 10, which equals 12. 3 would also go in the 10, so it's 15. And then you would put 1 into the 12 because it has the least amount. And then 10 would be in its own bin again. 11 would be in its own bin. 13 would be in its own bin. And 5 would go back into the 10 bin because it's the least amount. We end up with a minimum number of bins of 9.
Next fit decreasing.
Next fit decreasing is just like next fit, but all the numbers are from largest to smallest.
Okay, so you start with 14 in the first box, and then 13 goes in the next box, and the next box will be 12, next would be 11, next would be 10, next would be 10, next would be 9, next would be 8 and 7, so those fit together. The next one will be 6 and 6. Then a new box will be 5, 4, 3, and 3. And then the final box will be 2, 2, and 1. So the total number of boxes minimum is 11.
First fit decreasing.
This one is the same as first fit, but you take the numbers from largest to smallest.
You put 14 in the first box, 13 in the second, 12 in a new box, 11 in a new box, 10 in a new box, another 10 in a new box, 9, 8, and you take 7 and put it back with the 9 because it is the least amount. Then you do 6 with the 10, 6 with another 10, 5 with 11, 12 with 4, 13 with 3, 2 with 14, and then you have 2 and 1 left over, and they go in, they go in a new box. And then a 1 or 3 and 8.
Worst fit decreasing.
Worst fit decreasing is just like worst fit, but the numbers are in greatest to least order.
Alright, start with 14, new box 13, new box 12, new box 11, new box 10, new box 10, new box 9, new box 8 and 7, then go back to the 10, the second 10 with a 6, and the 9 with a 6, and then the other 10 has a 5, and then the 11 has a 4, 12 has a 3, 13 has a 3, 14 has a 2, then a new box has 2 and 1, and then the minimum boxes is 9.
This is optimal vertex coloring. Each vertex is assigned a color using the minimum number of colors. So the graph up there will help you know which points connect. So point A and point B would connect. Point A and point D would connect. Point B and point C would connect. B to E. C, where do you have C to B? So that's done already, and C to D. And then everything is done. So then our optimal color would be 2 because, for example, A and B couldn't be the same color because it's connecting. So A, C, and E would be all the same color, and D and B would be the same color.
A real-life example of bin packing would be loading and filling UPS trucks for delivery. For the optimal chromatic number graphs, a real-life example would be a teacher making a seating chart and not wanting certain people sitting by each other.
This is my last chance to ask.
This is optional vertex color. This is optional vertex coloring.